Hello, my name is Mr. Bryce, and we're working on the January 2011 Integrated Algebra Regents. We're starting at number 8 of the part 1s, which are multiple choice questions. These are parallel questions. They're not exactly the same questions. So if you're working in the green book, question number 8 is similar to this one, but not exactly the same. When x cubed minus 25x is factored, the result is I cover up the choices. The first thing that we notice, we only know how to factor quadratics in integrated algebra. That's an exponent of 3. So I'm going to think we have a greatest common factor. Hopefully the greatest common factor is x. I take a look, and yes, there is an x in all of the parts. When I do x cubed divided by x, I get x squared. I bring down the operation. I do 25x divided by x, and that's 25. Remember, we have to completely factor this. So let's take a look at this step in our problem so far. X squared, minus 25 is a difference of two squares. We also call them dots. Difference of two squares. Because it's a subtraction problem. X squared is a perfect square, and the square root of 25 is 5, so that's a perfect square. So when we factor the difference of two squares, we think to ourselves, first of all, what two numbers multiply to equal negative 25 and add up to be 0? Because x squared minus 25 is the same as x squared plus 0x's minus 25. That's why they have to add up to be 0. What two numbers multiply to be negative 25 and add up to be 0? That would be positive 5 and negative 5. We just factored it completely. Take a look at our choices. Don't get distracted by choice number 1 because they both have minuses. This one does not have the x as the leading coefficient or the leading factor. So our choice is choice 4. What did we learn? We learned that if the exponent is greater than 2, we know that there has to be a greatest common factor. We learned how to factor a difference of two squares, or also a trinomial. They multiply to be the y-intercept. They add up to be the linear function. Which ratio is represented by the cosine of angle A? As soon as I see anything that represents sine, cosine, or tangent, I open up my reference table, and I see that the cosine of angle A equals adjacent over the hypotenuse. Which fraction represents the cosine of angle A? I immediately see that I'm going to be standing on angle A. The adjacent is either going to be the 4 or the 5. I know that the 5 is the hypotenuse because it's opposite of the right angle. So 4 has to be the adjacent side. So 4 goes on top of the fraction. The hypotenuse is already the 5. We identified it because the 90-degree angle points to it. So 4/5. Let's take a look at the choices and see if 4/5 is one of our choices. There it is, choice number 4. Anytime you see a sine, cosine, or tangent question, we immediately open up to our reference table. We make sure that we have the proper ratio, adjacent over hypotenuse, for cosine. We identify the adjacent side and the hypotenuse side. Always identify the hypotenuse side first. Then the other side that your angle is touching is the adjacent side. The side that your angle is not touching is the opposite side. And then answer the question. So far, 1 through 9 have been pure vocabulary questions. Let's take a look at what number 10 says. Okay, here's another example for number 9. Which one is the sine of angle A? The sine of angle A is the opposite over the hypotenuse. Let's go over a little mnemonic right now to remember sine, cosine, and tangent. Oliver has a hat. And the last one is on always. Oliver has is sine, a hat is cosine, and on always is tangent. Or you can look at your reference table like I said earlier. So sine is opposite. We identify the hypotenuse first. The hypotenuse is 5. The other one that your angle is touching is the adjacent. So the third must be the opposite. Opposite over hypotenuse is 3 over 5. Choice 1. These are parallel to the regents question. And here's the tangent. I changed it to angle B. Why did I change it to angle B? Because you still have the same hypotenuse, but now, instead of the adjacent being 4, the adjacent is 3. Why is the adjacent 3? Because angle B is touching the 3 side and the 5 side. The 5 is already recognized as the hypotenuse, so 4 must be the opposite. Tangent is on always, which is opposite over adjacent, 4 over 3. You notice tangent is the only ratio that can be greater than 1. 4 over 3, choice 4. Parallel to question number 10. What is the value of the expression? The quantity x cubed minus y to the 0 quantity squared when x is -2 and y is 10. This is asking, can you use your calculator? X cubed, I'm going to put the -2 in parentheses, minus 10 to the 0 squared. How do you type this in your calculator? You put the parenthesis, you put the other parenthesis, you type in the negative sign, you close your parenthesis, you do the caret. 3 minus parenthesis 10, close parenthesis, caret 0, close parenthesis, square. You should know anything to the 0 power is just 1. This is -8. Now we have -8 minus 1 is -9. If you didn't have it in parentheses, your calculator may say -81, but it is +81. We take a look, see if that's one of the choices. It is choice 2. Taking a look at number 11, a student correctly graphed the parabola to help solve a quadratic equation. What are the roots in association with this graph? The roots are the same as the zeros. The zeros are where it crosses the x-axis. That's at 4. That's at -2. For this one, make sure that you write down that the roots are the same as the zeros. The zeros are the same as the x-intercepts. Hit pause, make sure you jot that down. Let's take a look at number 12. Which value of x is a solution to this equation? There are a lot of ways to solve this equation. First thing you might think of is, oh, I'm going to turn them both into decimals, and then I am going to subtract the 0.5 from both sides and then divide by 0.75. In this case, we do have nice numbers. 17/4 is 4.25 and 1/2 is just 0.5. But what happens if we don't have nice numbers? Let's approach it if we didn't have nice numbers. You will be able to find a common denominator. The common denominator is 4. Obviously 4 and 4 for that one. Does 2 go into 4 when you count by 2s? 2, 4, 6, 8. Yes, it does. So how many halves go into and fourths have a common denominator? Well, what do you multiply 2 by to get to 4? 2. So let's take a look at this. 3/4 plus 1/2 times 2/2 equals 17/4. So 3/4 x plus 2/4. 2 times 2 is 2. 2 times 1 is 2, and 2 times 2 is 4. Eating 2 slices of pizza out of 4 is the same as eating half of the pizza. That's half the pizza, our original statement. Equals 17/4. Remember, whatever I do to the left-hand side of the equation, I have to do to the right-hand side of the equation. I didn't change this number at all. 2/4 is the same as 1/2. But now I am going to change it. What I'm going to do is I'm going to multiply the left-hand side by 4. And I'm going to multiply the right-hand side by 4. I could multiply it by 4/1. When I multiply, four times 3 is 12. 1 times 4 is 4x. Plus, I'm still distributing. 4 times 2 is 8. 1 times 4 is 4. Equals 4 times 17 is 68/4. 1 times 4 is 4. Now, can you simplify these fractions? Of course you can. 12/4, and this isn't a trick, 12/4 is 3. So this isn't a trick, okay? 12 divided by 4 is 3x. 8 divided by 4 is 2. 68 divided by 4 is 17. Why did I say it's not a trick? I multiplied everything by 4, and what happened? Oh, the numerator. The numerator. And the numerator again. Okay? It's a mathematical process. There's nothing up the sleeve. It's not a trick. It works. What would I do? I'd write down this step, I'd write down this step, and I'd go right to there. Subtracting 2 from both sides, 3x equals 15. Dividing everything by 3, x is 5. Did we answer the question? Which value of x is the solution to the equation? We solved for x is 5, and it is choice 2. Let's take a look at the next question, see if we're going to do it in the next part or in this part. We'll do this one. What is the range of the data represented in the box and whisker plot shown below? I could have called this, what is the range of data represented in the Mr. Bryce and Mr. Burke plot shown below? It doesn't matter that it's called a box and whisker plot, but that's what it is. There's the box, and here are the whiskers. It's a box and whisker plot. Don't get confused in the name. What is it really asking you? What's the range? The range is the highest number minus the lowest number. 6 minus -9. If you can't count that it's 15, then try it on your calculator. Vocabulary word, range. The maximum minus the minimum. Maximum minus the minimum equals the range. Okay, so this ends the second presentation. The next presentation we'll start off on question number 14. Remember, if you have any questions, please feel free to ask them in class or from our after-school study period from 2:12 to 3 o'clock. Have a great day. Go on to the next lesson.